So how do we handle deriving functions with x's in denominators? Turns out, once you know what to do, it works exactly the same way as any other power rule problem. Just takes a little bit of algebraic manipulation, just like with radicals. Okay, so let's take a look at this first. Notice that we have this x to the minus 2 here. That kind of is indicative of what needs to happen with this 1 over x here. Turns out that we have x in the denominator. That's the same thing as x to the first in the denominator. So what we're going to do is we're going to flip up that denominator into the numerator so that we have a negative exponent. That's what negative exponents mean. It means that that thing with the negative exponent is in the wrong part of the fraction. Negative means bad. So then looking at this third term, it's going to be the exact same thing. We're going to take the x to the third in the denominator, bring it up to the numerator, and negate the exponent. Just using exponent rules. That's all we did. Now we know how to derive this. All it took was a little bit of algebraic manipulation. How do we derive this? I'm going to skip a couple steps without using arrows, and hopefully you'll be able to follow along pretty easily at this point. So it becomes minus 2 x to the minus 3 plus minus 1 x to the minus 2 plus minus 3 x to the minus 4. Just using the power rule there. Okay, now we need to simplify this algebraically. Nothing really changes with the first term. Second term becomes minus x to the minus 2, and then minus 3 x to the minus 4. Pretty straightforward. My hope is that you're getting pretty good at the power rule at this point, so you don't need to draw a bunch of arrows every single time you do this. It'll become second nature as you just do a bajillion different derivative problems. And you're probably going to do at least 1,000 by the time you finish Calc 1. So again, the moral of the story was convert your fraction with the x in the denominator, bring your x up to the numerator, and negate the power. This is going to be a very common strategy you see throughout all of calculus.